So basically, at this point, we are now entering the real world of analytical chemistry. Sinabi ko na yung real world because this is one of the four methods that we will discuss throughout the semester. Okay? So ito na talaga yung pinaka-chem. Yung ginagawa natin previously, ano lang yan, basic lang yan. But this time, legit chem na to. Okay? So ano na lang, just prepare your heart, prepare your mind. Ayan. So good luck. Okay? So gravimetry is one of the four analytical methods. If you can still recall, the four analytical methods are gravimetry, volumetric, electroanalytical, and spectroscopic. Okay, so gravimetry yung pinakauna doon. And this is the oldest analytical method. No? Oldest in a sense that even before chemistry, people are doing this. Okay? So bago pa man mag-chem, yung mga tao nagtitimbang na. Okay? So that's why I said that. That gravimetry is indeed the oldest and the most simplest form of chemical analysis. Okay? Because ano ba meron sa gravimetry? Basically, you just need to weigh stuff. Okay? Timbang-timbang ka lang ng objects, then, yan. You have your answers na. Diba? Okay? So, yan. For this session, starting this session pala, just be ready. Good luck na. Kaya yan. For now, ano lang tayo, basic discussion lang tayo. Pero sa mga susunod na meetings natin, medyo hihirap na siya. So, paki-ready na lang ang puso at isip. Okay? So, good luck. By the way, may nakalimutan ako i-share. Ayan. Include computer sound. Ayan. Okay? Ayan na. Okay, so again, welcome to this topic, and I think we can cover the entirety of this chapter within this week, but the downside is may holiday this week, no? Ay, hindi, wala palang holiday. Akala ko 25 na sa Friday. Okay, so wala palang holiday. So meaning, yeah, we can continue. I think we can finish this chapter within this week, no? Kasi konti lang naman yung slides niya. Okay? So, to be more specific, this is what we are going to cover for this session today. Okay? Just these topics. And then for the next meeting, itong remaining topic naman. Okay? So, yan. So, it seems na marami tayong i-cover today, but onti lang yan. Pinag-iwa-hiwalay ko kasi yung slide title. Kaya ganyan. Okay? But for this part, next meeting yung calculation na. So ngayon, pahinga lang muna tayo ng calcu. Pero next meeting, pipindot na naman tayo. Okay? So for now, let's just talk about the concept of gravimetric method of analysis, how it is done, and what are the things that you have to remember about it. And the next meeting, we'll do some calculations. So pahinga muna sa calcu today. Okay? So now, let's talk about gravimetric method of analysis. So again, when you say gravimetric method of analysis, it is just a form of measurement wherein you use the mass of the objects to infer the quantity of your substances. Okay? Kunwari, I have this gummy worms. I want to determine the sugar from it. What will I do? Of course, I will remove the sugars and then I will measure the mass of the sugar crystals here. Okay? So, yan. So, gravimetric, basta magtitimbang ka, you have your results na. Okay? And in analytical chemistry, this is one of the basic, okay, one of the basic and the fundamental type of analysis. Na? Even though na basic lang siya, its use is tested by time, no? Sobrang tagal na nito na ginagawa. Even before the modern chemistry, siguro panahon pa ng alchemy that time, wala pang chem, ginagawa na nila to. Okay? So, nag-alchemy sila, ginagawa nila to. Legit yun ha. Baka isipin nyo yung alchemy nasa anime lang. No, legit part ng history namin yun. Okay? Kaya kami ay mga alchemist. Ayan. Anyway, so ayan. Um, in the modern version of chemistry, gravimetry can be done in two types. No? We can have the precipitation method for gravimetry and the volatilization method for gravimetry. Okay? So again, yung gravimetry, dalawang uri yan. You have the precipitation and the volatilization. Okay? So ano yung unang papasok sa isip nyo when it comes to precipitation? Of course, may precipitates. Okay? So in precipitation method, you have your precipitates. And in volatilization method, basically, you are going to decompose your matter, okay, to determine the amount of substance present in it. Okay, so let's talk about precipitation method. In precipitation method of gravimetric analysis, what we do here is we convert our analyte into a precipitate. Okay, so yung analyte mo, gagawin mo siyang precipitate. And that means you should have a strong knowledge of your solubility rules. Naalala pa ba ang solubility rules? Hindi na. Alam ko hindi niya na naalala. But hopefully, maalala niya. No? So, hindi na namin i-discuss. But, just ano na lang, just recall the lessons last year. Okay? So, yun. So, in precipitation method, we make use of the solubility rules to tell whether we will form a precipitate or not. The target here is to convert them into a precipitate. Why? Because if your ions are suspended in your solution, you cannot weigh them. Kasi they are mixed in the solution. Hindi mo naman masaseparate yung ions from the solution, right? So, the target in gravimetric method, specifically the precipitation method, is to convert your ions into a precipitate so that you can accurately measure them. Because again, kapag solution yan, hindi mo pwede i-weigh yan. Kasi halo-halo sila. So gagawin mo, you convert all your ions into solid precipitate. Okay, gagawin mo siyang solid. And then, yung solid na yon, tutuyuin mo yon. Okay, so this solid, okay, so this precipitate, you will get it, no? If you filter mo yan, then you will dry it here. Okay? Then pagka dry, you get your mass. Okay? And that mass corresponds to the amount of the ions that is present in your solution. So basically, that's the um, main principle of precipitation method. Lahat ng ions na analyte gagawing precipitates. Then what's next? Your precipitate, since it is solid, it can be filtered, it can be cleaned, and it can be converted to a product of known composition. Eventually, that product will be weighed. Okay? So, ganun ang nangyayari. Yung ions, gagawing solid, yung solid, papatuyuin, lilinisin, and then titimbangin. Okay? So in gravimetric method of analysis, we commonly use this apparatus. Okay, this is called the crucible. Okay, the crucible is the apparatus that we use to dry our precipitates. So basically, after filtering this solid, you place it here, and then once placed here, you subject it to high flame. Okay, high heat flame, such as those coming from the Bunsen burner. Okay, so Bunsen burner. Okay, and in order for your crucible to be fixed, no, on this flame para hindi siya galaw ng galaw, we use the clay triangle. Okay, so clay triangle ang ginagamit so that hindi siya maggalaw-galaw. Okay, hindi pwede yung yung gauze wire, because gauze wire is used for heating liquids, but this time we are drying the chemicals, so we need to use clay triangle. Okay, we want the flame to really touch your crucible kasi, so that's why we use the clay triangle instead. And then that clay triangle is supported by your iron ring. Okay, fixed in your iron stand. Okay, so that is the typical setup for gravimetric method of analysis. Na? So you precipitate your analyte, you precipitate your ions, then the precipitate will be washed off, and then they will be placed inside the crucible, and in the crucible they will be dried with fire from the Bunsen burner or alcohol lamp, and then that crucible is secured by a clay triangle. Ayun. And then after some time, no, maybe around 10 minutes, no, ayun, um, pwede na siya i-weigh. Okay? So, yun. So, ganun ang ginagawa. Yung ano, basta tutuyuin lang. Okay? So, that's the main principle behind the precipitation method. Okay? Volatilization method. Okay? So, in the volatilization method, it's either you literally volatilize it or you convert it into products. So, kumbaga, in volatilization methods, there are chemical reactions that happen. Okay? It involves chemical reaction, just like precipitation. However, in volatilization method, instead of measuring the mass of solid, ito kasi solid yung may na-measure dito eh. In volatilization, we measure the mass of gas. Okay? We measure the mass of gas. No? Measure mass of gas coming from solution, coming from the sample. Okay? And that amount of gas can correspond to certain chemicals. Na? Okay? So, kapag nag-gain ng mass, may meaning yan. But generally, they lose mass. No? So, kunwari, you react your sodium bicarbonate. When you react your sodium bicarbonate, it will produce carbon dioxide. Okay? So, ibig sabihin, if nabawasan siya ng mass, that means carbon dioxide evolved from the sample. And then from the mass of that gas evolved, you can actually tell the concentration or the purity of your sample. Okay? So, ganun yung ginagawa sa volatilization. Okay? So, again, in precipitation, you determine the mass of the solid precipitate. In the volatilization, you measure the mass of the gas coming out from the sample. And all those masses, whether from solid or from the gas, you can tell uh, the concentration of your sample no, from the data you get in those two methods. Okay? So, pwede mo makuha yung concentration, purity, etc. Or even chemical composition. Okay? So, yun. Gravimetric method of analysis ang ginagamit doon. Okay? So, yan. So, yan yung two types of gravimetric method of analysis. Precipitation, titimbangin ang solid. Volatilization, we measure the mass of the gases. The common type of gravimetric method is the precipitation. Why? Kasi when we do volatilization method, it requires a special instrument. Okay? And that instrument usually costs around 1 million peso and above. No? Unlike in precipitation method, all you have to need is a beaker, a crucible, a clay triangle, and a heat source. Yun lang yung kailangan mo when it comes to gravimetric method involving precipitation. So that's why in chemistry, we always do precipitation. Okay? However, if your laboratory is well equipped, you can do volatilization. Okay? And now, since precipitation gravimetry is very much common because of the simplicity of the method, okay, ito yung ginagawa sa lab na. However, in preparing your precipitation gravimetry, okay, kapag gagawa ng precipitation gravimetry, there are so many things you have to consider. Okay? Number one is that you should be able to precipitate out your analyte. Okay? So, yung analyte mo, kailangan maging precipitate. So, that means you really have to look into your solubility rules. Okay? some analytes overlap with the solubility of the other uh, ions from the matrix, no? So there are many things that you have to consider, which is yung focus ng discussion natin today, okay? So for the rest of the discussion, we'll just talk about precipitation, gravimetry. Let's talk about how we can decide on how to proceed with this method, okay? Ano yung kailangan i-consider, what are the problems that we will see in the future, and how to address them, okay? So yeah. So before we begin with the discussion on the pros and cons of the precipitation gravimetry and the problems that we will encounter, let us watch a short video clip muna. I got this from YouTube, no, showing the precipitation method. Sadly, we cannot do it face to face, no, even though face to face classes already started, no. Pero pang higher year lang yan eh. So kayo, online lang. Okay? So sadly, we are still limited na. Kaya, let's just watch this video na lang muna. Okay? So this video will give us an idea on how to conduct gravimetric method of analysis. And then later, I will explain each steps. No? We will discuss the concepts and principle behind all those steps. So for now, let's watch what the analyst will do.
Hi, my name is Elise. We'll be talking now about the experiment on gravimetric analysis of a chloride salt. You will start by getting a salt sample which has a number on it. That is because these are unknown salts with different percentages of chloride by mass. You'll need to record the sample number so that at the end of the lab, your TA can give you the accepted percentage of chloride in the salt, and you want to make sure you get the right number. The first part of the experiment will be to weigh out a sample, one for you, one for your partner, of your salt. Use the analytical balances at the back of the lab benches and put the vial on the scale. Remove some of the salt from the vial into a 250 ml beaker once you have the initial mass of the vial. Put the vial back on. Take the difference in the two masses of the vial to find out how much salt you've removed. You want between 0.1 gram and 0.15 grams of the salt.
Nakita nyo, maski ba naman experiment, by partners na rin. Lahat na lang by pair. Anyway, so ang idea that Elise was telling us is you have to weigh your sample first. Okay? So, hindi pwede random amount of sample. Because later, when we do our calculations, makikita nyo that the amount of the sample is really important, no, in doing gravimetric analysis. Okay? Especially when you want to determine the percent composition. Okay? So basically, in the first part, she just reminded us to weigh specific amount of sample using an analytical balance. Okay? So analytical balance ang gamit. Okay? So hindi pwede top loading. And then what's next daw? Let's hear it from her.
You will then dissolve the sample in about 100 mils of water and have your TA add 1 ml of 6 molar nitric acid so that you will completely dissolve your sample.
Okay, so after you weighed a specific amount of your sample, tunawin mo daw syempre. Kailangan solution siya. You might be wondering now, what's the purpose of nitric acid? Ano yung purpose ng acid? So, later on sa discussion ko, ang purpose niya is for digestion. Okay? In chemistry, when we say digestion, it doesn't mean na you eat the chemicals. Na. Baka isipin niya yung digestion sa biology, no? Wherein you start chewing with your mouth. No? Hindi ganun. In chemistry, when we say digestion, it's just a way wherein you fully dissolve your compound using acid. No? Okay. Kunwari may mga buo-buo, lagyan mo lang ng acid, then they will all disappear. Okay. So that's the idea of digestion. So huwag kayo nakakain ng acid. Nagulat kami. Pag sinabi ko digestion, ganun agad. Shot agad ng acid. Hindi ganun yan. Okay? Okay. So ano lang. We use digestion in order to fully dissolve our analyte.
Based on how much salt that you measured, you will be determining how much 0.1 molar silver nitrate you need to add to precipitate out all of the chloride. So you'll measure that out using a graduated cylinder.
Bago tayo pumunta dyan, sabi niya, chloride yan, di ba? And the precipitating agent she used is silver nitrate. Why do you think silver nitrate is chosen as the precipitating agent? Anyone? Bakit silver nitrate? Hindi ba pwede sodium chloride? Hindi ba pwedeng ano na lang, nitric acid din? What's with silver nitrate and chloride? Ano nangyayari sa kanila when you combine them? What will happen? Ano kaya mangyayari when you combine silver nitrate and chlorides? Any guess? Nasa PowerPoint na yung sagot. Tingin lang kayo sa nasa screen niya. What will happen to the silver nitrate and the chloride ions? Just look into the PowerPoint, andun yung sagot. They will form precipitate. Ayan na. Laki-laki. So, yung silver nitrate and your chloride can do displacement reaction. Okay? Single or double displacement reaction. So, again, when you say double displacement or single replacement, magsaswitch lang ng partners. And according to the solubility rule, chlorides are insoluble in silver. Okay? So, kaya silver nitrate ang gagamitin. So that all the chloride ions present in your sample, they will all turn into silver chloride solid. Okay? Tignan nyo ano mangyayari. So,
and then add it to your dissolved salt,
ayan.
and you'll see this white precipitate form.
Galing. So, kanina, clear sila both. However, upon the addition of silver nitrate,
out using a
they
graduated
eventually
cylinder,
turn into
and then add it
precipitate.
to your dissolved salt, and you'll see this white precipitate form. This is your silver chloride, which is very minimally soluble in water. So once that's formed, you will start to heat it up on a hot plate. You want to heat it up so that these very small particles will come together, coagulate, and clump together so that when you filter your salt, it will not pass right through the filter.
Okay, so sabi niya, once you have your precipitates, you heat it para mag-compol-compol sila. Okay, dito kami nagkamali last year, before lockdown. Around February ata yan, ito experiment namin. Kasi sabi ng method namin, wag na i-heat. Yung pala, kailangan talaga i-heat. Ako naman, nasunod lang sa method. Tsaka, medyo worried na rin ako ng pandemic noon eh. February 2020. Yan. So, while we're doing that, medyo may concerns na rin. How will we proceed with the experiments na should ever magkaroon ng lockdown, which happened later that year. Okay, so yan. After precipitating it, hindi mo siya agad-agad i-filter. Yeah, solid sila. However, the particles are very fine. It's finer than salt, no? Mas fine pa yan sa sa baby powder. So, you cannot just filter it agad, no? Because some of them might pass through the filter paper. So, in order to make the particles bigger, okay, you heat it. Okay? Discuss natin later yan.
So you're going to heat it with some gentle stirring every now and then. Remember not to stir it too much because the salt is photosensitive and will decompose in light. You want to get it to the point where the salt is clumped on the bottom of the beaker and you can see through the supernatant liquid to the other side of the beaker. All right, we've been heating for a few minutes, but you can see there are some clumps on the bottom, but the supernatant liquid is still very cloudy. So we want to keep heating it without bringing it to a boil until that liquid is almost clear. When the supernatant liquid is clear or almost clear, You just need to check that you've added enough silver nitrate to precipitate out all of the chloride. You'll use a little bit more silver nitrate to make sure that you have precipitated out all of the chloride ions. So you will take a dropper and watch as you're adding a few drops to the supernatant liquid to see if any more precipitate forms where you're dropping it. If you don't see any, you added enough silver nitrate to begin with, and you're ready to stop heating it. Remove it from the hot plate and put it in your drawer to cool off so that it's not exposed to light. It takes on a bit of a purple color when it is decomposing in light. Remember to only open the desiccator when you're taking out.
Okay, marami na siyang sinabi. So, let me just summarize na. So, upon heating, di ba nakita nyo, before it's just cloudy na, it's just cloudy. If you let it stand, magiging parang baby powder lang sila. However, that is not really ideal because when you filter it out, ang messy. Okay, some of the precipitates might pass through the filter paper. So you might want to heat it until you see that the precipitate starts to clump together. That process is called coagulation. And then once they are fully coagulated, then that's the time you may filter it. May sinabi siya about testing, no? Whether enough na yung silver nitrate mo. Okay, you might want to add some more silver nitrate just to see if precipitates will continue to form. Sometimes kasi when you add a drop of silver nitrate, nagiging white yung part ng solution where you drop the silver nitrate ions. Pag pinatak mo, minsan bigla nag-white yung part na yan. So that means you did not add enough silver nitrate. So you might want to add more pa. However, if you drop your silver nitrate and nothing happened, the solution stays the way it is, no? That means you're done with the precipitation process. Okay? So, yung sinabi niya na pagpapatak ng silver nitrate, that is just to test whether all ions were converted into their correct precipitate. And then once verified, then you can proceed with the filtration. Okay? So the filtration here is not the typical filter paper and the funnel. Instead, what she uses here is the vacuum filter. Okay, if you can recall our discussion on chapter 1, in vacuum filtration, we need to use what's called a gauche funnel. No? Gooch. Tama ba spelling? Basta yan, a gauche funnel. Okay, so yan. So yun yung gagamitin pang filter.
Of the one that your partner uses so that you know which salt sample went into each crucible. When you are ready to start filtering, when you've taken the mass, you'll set the crucible onto the filtration.
Apparently, itong gauche filtration niya, yung gauche filter niya, it also serves as a crucible. Very advanced yon. Kasi yung typical gauche crucible na ginagamit sa FEU. Gauche funnel. Okay. So, ang typical na ginagamit sa chemistry, sa FEU, ganito lang. Okay? Yan, yung may pahaba. Apparently, pwede rin pala siya maging crucible na. I never encountered a gauche crucible. Ayan. So, ito yung ginagamit ni Elise sa video. Okay? Mayaman sila siguro. Pero in FEU, this is just what we have na, the gauche funnel. Ganito lang. Yan. So, something like that. That's Bruckner. This one is the gauche funnel. Okay? So, ang advantage with her apparatus is that wala nang losses sa mass. Okay? Everything that is precipitate will get stuck in your funnel. Okay, in the crucible. Anyway,
apparatus and ask your TA for help in getting this set up. and in how to use it. In this case, I'm demonstrating how to filter one sample. So I've plugged the other side, but normally you just would put the second crucible on this side here. When you are ready to start filtering, you just turn on the tap that's attached to your vacuum filtration apparatus, and that will create a vacuum so that as you're pouring your salt and the solution into the crucible, it will suck the solution through. You want your sample to be fairly cool when you get started. The first step is to decant the liquid through the filter. This means you want to get the liquid through the filter, but keep most of the precipitate still in the beaker. This is so that it will go a little bit faster if you're filtering just liquid, and so that we can rinse the precipitate before transferring it to the filter. So in order to decant, you will hold your glass stir rod across the mouth of the beaker like this and pour down the stir rod into the crucible. The stir rod will help prevent the bulk of the precipitate from going onto the crucible and will then allow us, like I said, to rinse the precipitate in the beaker when we're done. So you will continue to decant until all of the supernatant liquid has been filtered. So some of the precipitate did go onto the filter, but most of it is still in this beaker. The next thing that you'll be doing is rinsing the precipitate with some dilute nitric acid to ensure that the coagulated or the larger pieces of the salt do not break back up into the colloids, so the very small particles. So you'll be adding just a few mils of nitric acid to the precipitate in the beaker. To wash it, you will decant through the filter one more time. And then you add a few more milliliters of nitric acid to the salt. And this time, we actually want to transfer the salt into the filter. So this rubber piece on the end of the glass stir rod is called a rubber policeman. With the nitric acid and the rubber policeman, we will transfer the precipitate onto the filter. If you need...
You heard it correctly, no? Rubber policeman. Ang purpose niya is to police the precipitates. No? So, ganun. Basically, di ba nakita nyo in the video that she added some acid, no? Okay? So, mamaya madidiscuss din natin yung principle behind that. But the reason is, it just cleans your precipitate. It makes it firm. Okay? Kasi if you don't add the acid, hindi siya magiging solid. Okay? There is a chance that your precipitate may break apart. No? So, upon adding acid, you will ensure that they will still clump together. Okay? So, yan. And then, after adding acid, you put them into your funnel. Okay? Using a rubber policeman.
Some help getting the precipitate onto the filter. You can also use some water from your wash bottle to add some water to the beaker and to help you move it onto the filter. At this point, we want to test that any excess silver has been removed from the precipitate, because if excess silver is present, if light is also, if the salt is exposed to light and there's excess silver, it can break down the salt even further. So you will add some water to the filter, and you'll be having to check the water that actually drips through the filter, drips through the salt. Ask your TA for help at this point. You'll be simply testing the water by adding a few drops of hydrochloric acid. So as a source of chloride ion, if there was any excess silver dripping through the crucible, you would see a precipitate form as more silver chloride is formed in the washings. If nothing is formed, there's no excess silver, and you're ready to do the final rinses of the salt on the filter. That is just with 3 times 5 mils of acetone. And when you're done that, all the liquid's gone through the filter, you're ready to turn off the vacuum, put your crucible back into the desiccator so that you can carry it over to the oven and have a TA help you put it into the oven to dry. Ideally, you would like to dry it for as long as possible before you need to leave the lab. You need to record how long you heat it in the oven for, the temperature of the oven, as well as how long you let it cool in the desiccator before you take the mass of the crucible with the precipitate to see how much precipitate you actually got. You would like to dry it so that 2 successive readings of mass of the silver chloride are no different than 1 milligram.
Okay, so basically that's how you do gravimetric analysis now. So just to summarize everything she mentioned, first you have to select your correct precipitating agent. In this video, the precipitating agent is silver because chlorides form precipitates with silver. And then after that, you just add some acid to make sure that your sample is fully homogenized. And then you add your precipitating agent and you heat it further so they will start to clump together. Kasi if you don't clump them together, uh, there might be a chance that the precipitate may pass through the filter paper. Okay, so yan, and then once you form your precipitate, you filter it out. Okay, you allow your supernatant to pass through. Yung supernatant is everything else, no? Yung precipitate, yun yung gusto mo kunin. Okay? So you pass through your supernatant and then the precipitate will be collected here in your in your gouge filter or in the gouge crucible. And then yun. Then once you collected all the precipitates, make sure that everything is fully transferred. If not, you use a rubber policeman. Okay? And then once everything is transferred here, then you can start drying your crucible. Okay? So, ganun lang siya ka-simple. But, to be honest with you, it seems na madali lang, no? Kasi she was able to do it in 9 minutes. But when you do it in the laboratory, it will take you 6 hours, no? Just to ensure you have enough samples, no? I remember now, before the lockdown, February 2020 din, uh, isang buong araw kami nagpakulo lang ng water. So, 3 hours lab namin yan. So, tagal namin. Pakulo lang kami, then tinunaw yung sample. It took us a while na. Okay, syempre, you clean your apparatus once you have it, di ba? And then, you discuss things muna, and then you start doing the experiment. Natagal lang kami sa filtration. Kasi, yun nga, mali yung method na binigay sa amin. Because it should be, after precipitating, it should be heated. No? But according to the method we followed, i-stand na lang daw. So, ibig sabihin yung particles, hindi sila clump together. So, yung supernatant and precipitates, they are not fully separated. No? So, yun. So, it took us a while now. Nangyari nga, after class namin, nag-filter pa sila. Pero sinabi ko, iwan nyo na lang yan sa locker. So, ganun. So, matagal siya. Mukha lang madali, pero matagal. So, it will take you around 6 hours. However, kunwari, ikaw BS Chemistry, like me, if you're from BS Chem, you actually do gravimetric analysis in 1 entire week. Isang buong linggo kami nag-gravimetry. Okay? Kasi when you do gravimetric method of analysis, when you dry your material, you make sure that the weigh is constant. Okay? Yung crucible, wini-weigh mo constantly. Okay? For 2 days. And then yung precipitate, ganun din. You weigh it constantly, no? For several days. Until you got your data that is reliable. So, ganun kami katagal. Pero yung analytical chem naman namin in BS Chem program, 3 sems siya. Yes. 3 semesters na chem. Sa inyo kasi 1 sem lang. So, medyo basic lang talaga yung discussion. Ayun. So, 3 sem kami nagdudusa sa Anakem. Pero masaya naman. Okay. Dahil matagal yung time namin, we have the opportunity to actually get samples. No? Ilog Pasig, punta kami. Yung isang friend ko, pumunta pa sa province nila, Nueva Ecija. Doon nagbungkal ng lupa, dinala sa Manila. Ganun ka-exciting yung buhay sa camp. Okay? Ayan. Okay, anyway. So, ito, wait lang. Supernatant po ba yung liquid portion? Yes. In liquid portion, that's supernatant. Hindi natin gusto yon. Okay? What we want is the precipitate that is in the supernatant. Okay? So, yung supernatant, tinatapon lang yan. Okay? So, yeah. So, the most important thing when doing gravimetric analysis is that you have to have your correct precipitating agent. However, in choosing your precipitating agent, you need to make sure that it is specific to one ion only or selective to one ion only. Kasi sometimes in your sample, di ba matrix yan, meaning you have several ions in there. Okay, so for example, you want to quantify, let's say, silver ions. What if meron palang mercury doon? Okay, mercury 2. If you use chloride, okay, both of them will form precipitate. No? Para sila mag-form ng precipitate. So, in choosing your precipitating agent, it must be specific or selective, okay, to your analyte. Kasi di ba in the solubility rule, there are so many overlaps. For example, chlorides precipitate in the presence of silver, mercury 1, lead, di ba, etc. So, dun sila precipitate. So, you need to make sure that your analyte will be the one that will only precipitate, no? That will only form precipitate, not other ions. And lucky for you, everything is in the AOAC. Okay? So, lahat nasa AOAC. Okay? Kami, nung ginagawa namin yung Anachem, 3 semesters na Anachem, nagbabasa lang kami ng AOAC. Tingin-tingin kami ng method. So, yung ginagamit natin, yun din yung file na binabasa namin dati. Okay? Maswerte tayo kasi we don't have to really overthink about this because everything is given already in the AOAC. Okay? So, yun. So, we need to make sure that the precipitating agent is only specific to a certain sample or a certain analyte or ion. Okay? And then, since they will form a product, you have to make sure that your product is readily filtered and washed free from contaminants. Okay? So, meaning yung particle, dapat malaki siya. You heat it, and then you wash it with acid, no? To make sure that it is solid chunk. Also, make sure that it has very low solubility. No? Kailangan sure na solid talaga siya. No? Okay? In chapter 4, we will discuss about solubility. Yun yung KSP natin. No? Chapter 4 natin discuss yan. Okay? So you just need to make sure that it's very low in solubility, so that there will be no significant loss of your sample. Make sure also that it is unreactive with the air, especially if you are going to do the experiment for a while. So apparently, sabi dito ni Madam, kalimutan ko pangalan, Elise, si Ma'am Elise, sabi niya that the silver chloride turns pinkish in the presence of light. If you're going to do the analysis for a while, medyo matagal, hindi siya ganun kaganda. Okay? Hindi ganun kaganda yung kanyang precipitating agent. So, kung gusto mo matagalan na drying, then you might want to use other precipitating agent. Okay? So, yeah. Did you know that our transition lenses contains some sort of silver chloride? Okay? May silver chloride yung ating transition lens. AGCL transition lens. Silver chloride ba yan? Or something else? Okay? Ayan. So, silver chloride. No? Ayan. So what happens is that, ayun na nga, di ba sinabi ni Madam na in the presence of light, it turns pinkish, no? Pero in some amount, no, if you change the amount of silver, it actually turns dark. Ayan. So, ayan. Nagiging darkish siya. So, yun yung mga nasa photochromic lens. For example, my lens now is transparent, but when I go outside, it turns dark. Okay? So, yan. Yan yung nangyayari sa video niya. Okay? Share ko lang. However, if you want to do the experiment for a very long time, then you might want to choose other precipitating agents that doesn't react with the atmosphere or even the light. No? And again, all of them are included in the AOAC. Also, you must know the composition, okay? Meaning you know the chemical formula of your precipitate. And knowing the chemical formula is very simple, okay? For example, you have your silver ion, chloride ion. How will you determine the formula? You just do the crisscrossing, okay? So, ganun lang. So, you should be able to know how to, what is the formula of the precipitate, okay? So, yun lang. So, once you are done with the precipitation, then makikita mo na yung white, no? Yung white cloud, no? So, precipitates, they tend to settle out of the solution, no? So, naalala nyo pa ba yung video ko dati? So, let me just pull the video from my drive, okay? Pakita ko yung video kung naalala nyo pa. Hindi yan. So, kaya yun. Ito ba yun? Ayun. So, dito, do you still remember the precipitation reaction last time? Okay. Ayan. So, good morning everyone. I'm Sir. So, diba, this is a precipitation reaction here, okay? So, the precipitation reaction, they actually form solid chunks, no? And those precipitates tend to settle down. Okay. Yan. So, una, cloudy lang siya. Okay. However, over time, they tend to settle down. Okay. So, in gravimetry, you will collect that precipitate. No? Yan. So, anyway, ayan. So, precipitate are large particles, no? And they are considered for gravimetric analysis kasi they are easy to filter, meaning they are easy to collect. And typically, they are pure. So, yung precipitate usually, almost 100% of it ay yung analyte mo in the salt form. Okay? However, there are actually two types of precipitate na. So, it seems na yung precipitate natin, yung ganito lang, no? Solid lang na. But in reality, hindi lang siya crystals, no? Dalawa yung uri niya. We have the colloidal suspension and the crystalline suspension. Okay? So, dalawa yung types ng precipitates, the colloidal and the crystalline. What we want is the crystalline. Why? Because for crystalline suspensions or crystalline precipitates, the particle size is so big that they can be affected by gravity. Okay? Yung gravity, since malaki yung particles niya, hihilahin ng gravity yung particles. So, they tend to settle down quickly. Okay? So, just as shown here. No? So, originally, it's very cloudy. However, if you just let it stand, all of the crystals will settle at the bottom of your container. That is what we want in gravimetry. However, in some cases, colloids appear. Okay? So, what's the difference between crystalline and colloids? Na? So, crystalline, yung particles niya, they are about tenths of millimeter or greater. So, ibig sabihin, it's big enough to be affected by gravity. But for colloidal suspension, the particles are in the nanometer scale. Okay? So, around nanometer scale nga. Okay? So, this is nanometers. So, super tiny niya. That sometimes it is not that much affected by gravity. So, it remains suspended na. For example, this one. Okay? Para siyang gooey. substance. Okay? So para siyang gooey substance that you really cannot let it stand, no? Kasi hindi sila nag-solidify sa ilalim. Okay? So this is one of the problems, especially when we deal with iron hydroxide. Okay? When you quantify iron hydroxide, yun yung nagiging problem namin. Iron 3 hydroxide. This is how it looks like. Ayan. So, colloidal siya. Mahirap i-filter yan. Okay? Kasi minsan, bumabara yan. Or minsan naman, lahat sila tumatagos. So, it's a pain talaga to deal with colloidal precipitates like that. What we want, yung crystalline. What we don't want, yung colloidal. So, what will you do, no? In case na may makita kang colloids forming? So, there are many ways to address that. Okay? So, let's go into the concept muna on why there are different particle sizes. Bakit yung iba crystalline, bakit yung iba colloidal? Well, it has something to do with the von Weimar equation. Okay? So, this equation, von Weimar, so obviously German, so ang W letter V, ang V letter F yung pronunciation. So, in this equation, this is equation of relative supersaturation. So that's Q minus S over S, wherein Q is the amount of your solute, and S is the solubility of the precipitate. Na? Wala tayong isosolve dito. No? Just the main idea lang. So according to this equation for relative supersaturation, when this ratio is small, meaning that your crystalline solid is more likely to form. However, when this ratio is large, it means that your precipitate tends to be colloidal. Ibig sabihin, mahirap i-filter. So, when do we have a small crystalline solid? Kailan daw tayo nagkakaroon ng small na relative supersaturation? So, ganito yung nangyayari. Diba, naalala nyo na ininit niya yung precipitate? Okay? Yung solution ng precipitate. Apparently, when you hit the precipitate solution, what happens is that the solubility of your precipitate increases. So, since lumalaki yung denominator, the ratio decreases. Pag lumalaki denominator, yung overall quotient lumiliit, di ba? So, that actually helps. No? Yung heating of the solution helps you to actually make the precipitate bigger. Okay? So, kunwari, ayaw nyo ng colloidal precipitate, you may want to put this in warm water. Not boiling, warm water lang. Because the heat causes the relative supersaturation to be low. And kapag mababa to, you will form a precipitate. Otherwise, magiging colloidal yan, like this one. So, ano gagawin nyo? Iinitin nyo yan. Okay? So, initin nyo lang. So that they will clump together to form a solid chunk. Sir, pwede po ba gawing crystalline yung colloids? Yan nga. Iinitin mo siya. You just heat it. Yung colloid para maging buo-buo sila. Okay? Yun yung process ng heating. Okay? So, yan. Upon heating, it actually allows your particles to grow. Na? So, basically, ito pala yung idea ng precipitate formation. So first, you have your clustering of your ions. Okay. So for example, in the video I shown earlier, you have your silver ion and then your chloride anion. So basically, those ions will come together by electrostatic forces. Okay. Meaning lang yan, yung positive attracted sa negative, but they will form precipitate, meaning magdidikit talaga sila. Solid yung kanilang bond. And those AgCl that are combined together, they will cluster together to form the nuclei. Okay, so magna-nucleation muna. And then once you have a nuclei, which is a solid, then other clusters may join them. No? Yung ibang clusters ng AgCl, pwede sila kumabit sa nuclei mo. Okay, so they can attach to the surface of your nucleus, causing your particles to grow. Yun yung nakikita nyo sa video, di ba? At first, it appears na milky lang siya, but upon heating, naging solid chunks na yung precipitate. So that is because heating allows the growth to occur. May nuclei na. Yun yung white na. However, if you heat that, it speeds up the growth of the particle. Okay? So, ganun yung pinakakwento. Ayan na. Basically, yan na rin yung sinabi ko. So, in the nucleation process, basically, your clusters of ions join together to form a solid. And then, those solids clump together, okay, to form to cause the particle to grow. Okay? So magkakaroon muna ng nuclei, and then other clusters will attach on the surface, causing the particle size to grow. And it will grow big talaga. Okay? So, how do we control the particle size? So, yun na nga. Number one is to increase the temperature. Just as I told you, when you increase the temperature, that increases the solubility of the precipitate. And according to the relative supersaturation, this is the equation again. So since lalaki ang ating denominator when you heat your sample, upon heating the solubility increases, right? That causes your relative supersaturation to decrease na. Okay, and that forms the precipitate. Okay, so ito yung general trend. Increased temperature increases solubility. And since the solubility gets increased, your relative supersaturation goes down quickly. And as it goes down quickly, you form precipitates. Okay? Kasi kapag mababa yung temperature, mababa solubility, probably you will form colloidal precipitate. Okay? Ako, I'm very much aware of this kasi in chemistry, organic and analytical, ginagawa namin to. Kapag malamig, para lang siyang gelatin. However, when you heat it, namumuo siya. And actually, meron ito sa bahay ninyo. Ano example ng colloid sa bahay? Milk. Diba? When you heat the milk, what happens? It curds. Okay? Nagko-curd siya. So, yung gatas, initin mo, magko-curd siya to form the crystalline precipitate. Pero hindi siya crystals, ha? Parang ganun lang yung idea. Lumalaki yung particle size. Okay? Try nyo sa bahay yan. Okay? Yung milk, initin nyo. Milk curdles upon heating. Ayan. O kaya sa gatas, kaya sa kape, ganun din. Diba? When you pour milk, yung mismong milk talaga from cow, lagay mo sa gatas, may ganyan-ganyan, nagko-curdle siya. Because it has something to do with the relative supersaturation. Increasing temperature increases the solubility of your substance, causing the relative supersaturation to be decreased, no? And that causes the precipitate to form. Okay? Kaya yung ating milk nagko-curd in the presence of heat. Okay? So the next time na magkape kayo with milk, alam nyo na. Okay? So yan. So actually, ako ginagawa ko when this happens, I just scoop out the milk, no? Yung milk, kinukutsara ko lang paalis. Yan. Okay, pwede nyo namang kainin. Okay? Okay lang naman. So yan, so that's an example of one way to control the particle size. No? So milk as a colloid, nagiging curd siya. Nagko-curdle siya, magiging solid chunk siya by just increasing the temperature. pH can also be used, no, as a way to control the particle size. Katulad na lang sa milk din. When you put acid in your milk, what will happen? It also curds. Okay? Nagpo-form siya ng curdles. Okay? So, hindi lang sa mainit. Pwede rin siya sa acid. No? So, it also forms curdles. No? Pag nilagyan mo ng suka, ang kape. And did you know that yung cheese, dito nang gagaling? So if you want to make cheese, you just use your milk, no? Add vinegar, and then once it curdles, you collect them. And then yung collection ng curdles ng milk mo, ipe-press mo, and then may iba ka pang gagawin sa buhay. And then eventually magiging cheese siya. Okay? Yan. So, yun yung pinaka-common example when it comes to controlling particle size. Increase the temperature, precipitates form. Change the pH, precipitates form. Okay? So, at home, you can use the milk as your logic. But in chemistry, ako, ang common example ko doon ay yung iron 3 oxide. Iron 3 hydroxide. Okay? Kasi kapag malamig, ganito itsura niya. Ayan. Pag ininit mo yan, magkukumpol sila. Okay? So this is how it looks like when it is cold in the lab. Ayan. But upon heating, solid chunk na yan. Okay? Ayan. So ito lang mga tatandaan nyo ha. Ito yung lalabas sa quizzes eh. Okay? Not the terms, no, but yung mga ways to control. Okay? Yung mga reasoning. Okay? And so yan, speaking of colloidal precipitates, sabi nga natin that your colloids can be converted into a solid chunk, no, by coagulating them. Okay? And coagulation can be hastened by heating, stirring, or adding electrolyte to the medium. For example, acidifying your solution. Okay? So what happens when you acidify your solution? For example, in milk, what happens is that there will be a sphere of ions here wherein yung mga particles mo, pwede sila kumabet. No? Due to the presence of the acid, let's say nitric acid, no, they actually help your adsorption process to speed up. Okay? So, mangyari in the adsorption process, didikit dyan yung mga ions quickly. Okay? Mas mabilis yung pag-combine nila quickly. Okay? Ito rin yung reason why earlier, si Ma'am Elise sa video natin, hindi ko naman siya kilala. Basta si Elise sa video, sabi niya, we need to add some acids to the precipitate while filtering it. Why? To make sure that it will stay in the solid form. Kasi if it tends to be colloidal, then sayang, masisira lang yung crystals mo. Okay? So, yan. So yun, adding acid causes the absorption process to speed up. Okay? So didikit yung mga ion sa surface ng iyong precipitate. Okay? So yun na nga, improving particle size. The particle size can be improved by maximizing S, minimizing Q. So ito yung nasa equation ng relative supersaturation. As long as you maximize the S by increasing temperature, your relative supersaturation will decrease, causing the precipitation to process quickly. Another way to increase the particle size is to digest your crystalline samples. Okay? So ito yun, yung process ng adsorption. So when digesting, meaning you add acid, no? And when you add acid, your precipitates will clump together. Mas maganda yung clumping nila together. Okay? So yan, yun yung mga kaganapan when it comes to precipitation. So again, let's just recall everything I said. Yung precipitates, they are good because they can be affected by gravity. But there are two types of precipitate. We have the crystalline and the colloidal. For crystalline, that's fine. That's the target kasi they tend to settle down, meaning they separate well with the supernatant. However, if that's colloidal, then it's kind of hard to deal with because sometimes they don't settle down. No? And if you filter it out, it can clog the filter paper or pwedeng hindi siya ma-filter at all, mag-pass through lang. For example, yung milk, when you filter it, everything just passes through. So in order for you to control that, you have your relative supersaturation. So basically, the idea is that you increase the temperature so that the relative supersaturation decreases. And when your relative supersaturation decreases, you form your precipitate, just like your milk. Milk is a colloid, but upon heating it, it turns into curdles na nagka-curd sila. So pag nag-curd, you can separate the solid chunks. You can also do pH control, just like in milk. Upon adding acid, your milk starts to curdles. Kaya yung milk kapag panis na, buo-buo yung nasa ibabaw. Proteins yan. Okay. Pero wag nyo kakainin yan kasi panis eh. However, if you just deliberately added acid na, pwede naman kainin yan. Kasi siguro gagawa ka ng cheese. But if bacteria yung nag-produce ng ganon, okay, kunwari panis na, wag nyo na kainin yan. Kadiri na yan. Okay? So again, for colloidal precipitates, you just coagulate them by the same principle we discussed in this previous slide. Okay? And then yung addition ng electrolyte is basically digestion. You can add acid to make sure that your colloids turn into crystals. Forbidden yogurt. Kadiri kaya. Nakita ko yan sa dati sa ref. Nung nagdo-dorm ako. Siyempre, di ba may mga ref sa dorm. Pagbukas mo nun na may mga gatas na may layers na eh. Kadiri naman ta. Malapit na uli face to face, so makaka-relate na kayo sa kwentong dorm. Okay. Nakita-kita na lang doon. Anyway. So yan. So ganun yung ways no to resolve the problem when it comes to colloid na. So you just heat it or you control the pH or you can just add acid na to digest it further. Pero did you know that sometimes in crystalline formation may problem din? Okay? So in crystalline process, sometimes may problem. And there are 4 types of problems na tawag doon sa kanila in general ay co-precipitation. Okay? So in the co-precipitation, co meaning kasama, mag-precipitate, di ba? Kaya cooperative kasama sa operative. Okay, co-op. Dito naman, co-precipitation, meaning sometimes yung unwanted substances mo naiipit sa loob ng precipitate, no? And there are 4 types of co-precipitation. You have your surface adsorption, mixed crystal formation, occlusion, mechanical entrapment. So you can read all of them individually, pero isa-summarize ko na lang. Okay? So sometimes kasi, remember, ito, when your particle growth happens very quickly, super bilis, it appears na the other ions present in the solution might get trapped. Okay? So imagine mo yan as beach goers. And then yung particle growth, that is the wave. Okay? Parang tsunami. What will happen? Kunwari, ikaw nagbi-beach, das ito yung wave. Pag mabilis masyado yung particle growth, ang mangyayari, instead of the ions or yung mga beach goer na makaalis, natatrap sila sa loob ng wave, di ba? So they get trapped inside the wave. So sometimes that happens to crystalline precipitates also. If the particle growth happens quickly, then yung ibang ions, they tend to have no time, no? They have no time to escape. No? So kaya naiipit sila sa loob, no? So pangit yon. Why? Because that causes the mass of your precipitate to increase, resulting to inaccurate result. No? So yan. So there are 4 types of co-precipitation, yung pagkakatrap. First is the surface adsorption. So dito naman nangyayari yung contaminants mo, the other ions that are not wanted, hindi sila yung analyte, they get trapped on the surface. Okay? So sa surface sila natatrap. How to improve it? Basically, you just digest it, no? Maglagay ka lang ng acid. Or in some cases, you can do reprecipitation. Ibig sabihin, you precipitate it again. So yan yung mga means to address surface adsorption. So again, in the surface adsorption, on the surface of the particle growth, dun dumidikit yung other ions. How to address it? You do acid digestion or you do precipitation again. Dalawang beses mo uulitin yung precipitation. Okay? For the mixed crystal formation, ito naman, if you have other crystals, no? Yung isang crystals, then isang crystal, nagdikit sila, minsan may natatrap sa gitna. No? So, yan. Same process lang din with surface adsorption, yung pag-minimize yan. For the occlusion, here naman, instead of ions yung natatrap, ang natatrap dito is yung compounds. No? For example, yung water molecule na trap sa loob, occlusion yan. Kaya, let's say, may sugar molecule that is trapped inside your crystal, occlusion yan. Yan. So, yung mechanical entrapment and then itong mixed crystal formation, they are very similar to one another. Okay? So, how to address co-precipitation issues? Number 1, you can do acid digestion. Number 2, you can redo your crystallization. You do reprecipitation. Okay? So, yun lang yung ways to address that. And siguro number 3, the most important is to allow your precipitate to take some time to happen, to form. Okay? So, hayaan mo lang siya mag-form for a very long time. Siguro mga 1 hour. Hayaan mo lang siya makatenga. Okay? So, ayan. So, ayan ha. So, yun yung co-precipitation. Nag-overlap yung ideas nila. Okay? But, ayan. Ito, make sure that when you do your precipitation, it must be homogeneous solution. Kailangan homogeneous. Kasi kapag yan ay heterogeneous, edi mas possible yung co-precipitation. So, that's why in the first part of the video, yung ginawa ni Madam Elise sa video, naglagay siya ng acid down just to make sure that everything is completely homogenized. Because if they are not completely homogenized, then co-precipitation are more likely to happen. Tapos ano na ginagawa? Then, pag meron ka ng precipitate, you dry it. Okay? So, ida-dry mo lang siya. So, normally, in drying your precipitate, it takes a while. And just as I mentioned you, when we were doing this when I was in college, it took us 1 entire week. Lahat kasi dinadry namin. The apparatus, the precipitate, the chemicals we are using, everything needs to be dried out. Ganong katagal. Okay? So, bakit kailangan i-dry? Just to ensure na yung mass is constant. Okay? So, for example, look at this graph here. So, this is a thermogravimetric thermogram. Okay. So, as you can see here, initially, you have high mass. However, over time, since you are drying the chemical, nagiging constant na lang yung mass. Okay? So, yan. We need to make sure that the mass is constant. Okay? So, once na mag-constant na yung mass, then you can do your calculations. Okay? For every compounds, there are different tendencies. No? Minsan, the change in mass only happens once, and then for the rest of the time, constant na siya. So, siguro yung change in mass na yon, that's probably due to the moisture. Okay? So, ito yung gagawin ninyo sa experiment. No? Kuha kayo ng dahon. Tapos, i-open natin siya. Okay? So, don't worry, ako ay naghahanap ng dahon, pati ng tawas. Kailangan kasi natin ng tawas dan. Naghahanap ako ng tawas. So, wala naman ako mabilhan. Sa kaya nakakabili nun. Baka may idea kaya. Last time kasi nasa Quiapo ako, but I wasn't able to go to yung side ng tawas. Di ba kasabay yun ng mga ng mga hala-halaman nila. Hindi ako nakapunta doon, sayang. Anyway, so in case na may alam kayo mabibilhan ng tawas, bumili na kayo. Ako naghahanap pa lang ako. So anyway, ayun, gagawin natin, we will dry it using oven and then we will create this kind of graph, no? Pero instead of temperature, over time yung usapan natin. So we will graph the mass and when then once it becomes constant, then pwede na natin gamitin yung data natin. Okay? So yung initial decrease sa mass, it's probably due to moisture, no? And onti lang naman yung decrease sa mass yan. However, if you see that our graph looks like this, no? There's a steep change in the mass, pag ganon, then that's probably due to the water that is in the solution, in your crystal, meaning you have your hydrated crystal. Kapag moisture lang, ganito lang yung graph niya. Okay? Onti lang yung decrease sa mass, then constant na. But if you have hydrated crystal, like tawas, if you graph the change in mass, it's the slope is very high, no? Para siyang pag ganun, then suddenly mag-steady siya. In some cases, chemical reactions do happen. So upon heating, some chemicals tend to decompose, no? For example, calcium oxalate. When oxalates become heated, they turn into carbonates and eventually into oxide, no? So when you graph it, it seems na multi-step yung process. So ano meaning niyan, no? So medyo hindi reliable yung data agad-agad. So you really have to increase the temperature further just to make sure that you have your calcium oxide na as your precipitate. Okay? So yan. Pero hindi natin gagawin yan, ha? Ang gagawin lang natin sa lab is this one, no? Yung moisture wherein there will be a there will be a small change in the mass, no, over time. And then for the hydrated salt, look for tawas. Bibili ako sa palengke siguro. So hanap ka ng tawas, then makikita mo when you graph that, medyo steep yung slope niya. Okay, at first, then eventually it will get constant. Okay? So yan. For this one, it means na there are some decomposition reactions happening. Okay? Ito, decomposition reaction. Okay, so decomposition reaction typically occurs in organic substances. Okay, so for example, you have your oxalate, it turns into carbonate and eventually into oxide form. Okay, so ako nung thesis ko, may ganyan din ako. Let me just share you my data. Kaya dito tayo sa graphs. Saan ba yan? Ayan. So this is the thermogravimetric analysis. Huwag nyo pansinin yung red kasi naiinis ako sa UST dahil dyan. Sila yung dahilan yan eh. Naiinis ako. Kasi sabi nila, ay sir, ganyan talaga. Sabi ko, wala. Nagpa-consult ako dun sa mga experts. Sabi nila, ano yan, baka na-shutdown yung instrument. Kasi imagine mo, naging 0 daw yung mass, tapos eventually bumalik sa 80%. Ano yung magic? So, sinabi ko sa UST, baka naman pwede ulitin nyo yung analysis ko. Sabi may bayad. Sabi ko, di wag na. Sa loob ko na eh. Anyway, buti na lang yung blue data, okay siya. So yung blue data, may glucose yan and acrylamide. So as you can see, there are several steps no in the decrease of mass, no. So siguro itong first part, this is due to the moisture. And then you see here, may sudden change sa mass, probably. This is due to the decomposition of nitrogen gas from acrylamide. May nitrogen gas na nag-evolve. Then eventually, may sudden slope again. Probably this is the decomposition of sugar. Nagde-decompose na yung sugar ko into carbon dioxide. Okay? So, yun yung mga interpretation namin dyan sa chemistry. So, at each point, there will be certain chemicals na nababawasan doon. For example, dito at 60, then suddenly naging 20-ish. Di ba yung molar mass ng carbon dioxide ay 46? Pag sinubtract mo yan, 46 yan. So, probably CO2 to. Ito naman, 14 yung difference niyan, around 14. So, probably this is just nitrogen gas evolving. So, yun yung mga ginagawa namin sa chem. Ito, tuturuan namin kayo niyan sa spectrophotometry. Yan. Para pag nag-thesis kayo, ready na. Okay. Anyway, so yan. So when drying, there are different interpretations. Sometimes the mass is just minor lang yung difference. That's probably due to the moisture. However, if yung mass mo continually siya nagde-decrease over time, consistent yung decrease over time, probably you have a hydrated crystal, just like tawas. And then, if ang decomposition niya ay magko-constant, then bababa, then magko-constant, then bababa, then probably there is a decomposition reaction happening when you dry out your sample. Okay? So, for the sake of simplicity, ito lang dalawa yung gagawin natin sa experiment. Okay? So, yun. Dalawang types lang, drying lang tayo. Ito, calculation, next meeting na yan. Okay. And so we're done, no? So basically, that's the concept of gravimetric method of analysis. Okay, just to summarize everything, so puro kwento lang talaga tayo today. There are two types of gravimetric analysis. One is precipitation, wherein you use the solubility rules to convert your analyte into precipitate. Next one is the volatilization, wherein you evolve gases from your substance, and depending on the amount of gas you evolve, you get the empirical data out of it. No? And then in precipitation, this is commonly used in chemistry because this is simple, inexpensive, and madali lang. We watched the video about it. So Google nyo na lang yung video na yan. And these are the things we need to remember when doing gravimetry. Number one, the precipitate must be ideal. It must be specific. Okay? Kasi if your precipitating agent is not specific to your ion, then there might be errors when it comes to your measurement. Lucky for us, everything is in the AOAC. So you don't need to start from the scratch. No? So you have the methods already. You just follow it. No? And then one important factor when doing gravimetric analysis is the determination of the particle size. Too big particles are better kasi they can be easily filtered, but too small particles are kind of a mess because sometimes they pass through the filter paper. So what we want is to make the particle size big. Okay? We don't want colloidal kasi kapag colloidal, sometimes they pass through. But kapag crystalline, they are big enough to be collected by the filter paper. And there are many factors that causes the particle size to change. Yun yung pH and the temperature. So when you increase the temperature, the relative supersaturation decreases, causing your precipitate to form. Okay, bigger. Katulad na nasa video. Diba? Kita nyo, nag-white cloud siya, but upon heating, over time, they all clump together. Sometimes pH can be used to increase the particle size, such as yung milk. No? So yung milk, colloid yun. When you filter it, nothing gets collected. But when you add acid to it, vinegar, and then you filter it, you collect your proteins na, specifically casein. Okay? And yung casein minsan nilalagay siya sa whey proteins. No? So for the bodybuilders dyan, you really need milk din. Hindi lang whey protein. Mag-milk din kayo for minerals then. Okay, so for colloidal particles, you need to coagulate them by heating, stirring, or adding electrolytes such as acids. Na tawag doon digestion. Okay, however, in precipitate formation and crystalline precipitation, there are some problems also that we experience. For example, kapag super bilis niya mabuo, there are co-precipitations that can happen. Pag occlusion, these are molecules getting trapped into your crystals. Pag mechanical or mixed crystal, okay, minsan pag yung dalawang nuclei nagdikit, may natatrap sa gitna. Okay. For the surface adsorption, all the unwanted ions kumakabit sa ibabaw. Okay. So how do we address the issue of co-precipitation? Number one, you do acid digestion. Okay. Number two, you can redo the reprecipitation. Okay? You do reprecipitation. Ulitin mo na lang from the top. Okay. Then when we have our good precipitate na, you can dry it, and depending on the thermogravimetric data, you can have different interpretation. If the mass change is just tiny and then suddenly it nag-flat out siya, that's probably moisture lang. No? So ito yung gagawin natin sa dahon. Kuha kayo ng dahon, kunin natin yung moisture content. And then for hydrated crystals naman, meaning crystals with water, there is a consistent decrease in the mass of your sample. So consistent yung decrease niya, okay, until mag-flat out siya. Okay. And then sometimes iba-iba yung steps ng decomposition. Minsan constant, then suddenly decrease, constant, decrease, etc. So there might be side reaction that happens. Okay. And yung side reaction na yun, that can actually give you a hint on the chemical composition of your matter. So that's what we do in thermogravimetric analysis. Okay. So ito yung pinakita ko sa inyo kanina. Okay, so depending on the percentage of the decrease, we can tell what compounds evolved, no? Okay, from the material. Ayun lang. Okay, so I think that's it for the laboratory class today. So okay na tayo with the concepts. Next meeting will continue with the calculation. I decided to just do the concept lang today para naman may pahinga. So next meeting na lang tayo mag-calculate, ha? To be honest with you, nauumay na rin ako sa calculations. Anyway, so I hope you learned something about the process of gravimetry, no? So don't worry, mag-update ako once na meron akong makitang tawas. Kasi ide-demo ko yung experiment. Okay? So for now, just stay safe, no? And see you again this Friday. Friday, yeah. Nasa isip ko kasi is 25 na 18 pa lang pala this Friday. Okay. So this Friday may class tayo. We'll finish gravimetry. Then siguro after natin ma-finish yung gravimetry, we can proceed with chapter 4, no? Para tapos na. Okay. And then on Feb 25 there will be no classes. People power yan. Okay. So the anniversary of, okay, ang ating Fourth Republic. Diyan na pinanganak. Okay? So I'll see you again next time, no? So for now, take your lunch muna, no? Kasi I'm also hungry. So I hope you learned something today, and I'll see you again this Thursday. Friday. Bye-bye, ingat, and stay safe, no? So happy lunch to everyone.